So how can we now get our data back from Firebase to our app? Well, for that, of course, we want to go back to the grocery list screen, to this widget, and there we want to send a GET request to Firebase because I mentioned before that in the end it's such a GET request that gets you data from there. But before we do that, we have to do one other thing. We have to make sure that we wait for this POST request to complete. Otherwise, if we do go back too early, we might not be able to fetch the data yet because it might not have finished sending to Firebase yet. It might not be stored there yet. Because with HTTP requests, you have to understand and keep in mind that they take some time. Not a large amount of time typically, but a few milliseconds or seconds. Because after all, a request must be created, must be sent to the backend, and the backend then must handle that request, do its work, for example, store the data in a database, and then the backend needs to create a response, a success or failure response, and send back that response to your app. And in the end, it's this response we want to wait for, because then we know that everything worked, or if it failed, we know why it failed, because we only know whether everything worked and that the data was stored once we have that response. And it's only thereafter that we should try loading or manipulating that data on that server. So that's therefore the next question. How can we wait for that response? Well, the POST method of this HTTP package actually returns some data. It returns a future that eventually resolves to a response object. And you learned about futures earlier in the course already. Futures are these objects which will eventually give you access to other data. And it makes sense that POST yields such a future because we don't have a response instantly after executing that code, but instead only once the server is done with its work. That's why POST gives us a future that will eventually give us access to the response. Now, as you learned earlier, there are two main ways of getting access to that response data here in this case. You can add a then method here on the result of calling POST, so chained on the POST method in the end. And then you can pass a function to then, and in here you would get your response, and then here you could work with that response. Alternatively, since this can be a bit inconvenient to write, you can convert save item to an async function by adding the async keyword here. And this then allows you to await this response by adding the await keyword here in front of the method that yields the future, because await is meant to be used on futures. And then with await added here, Dart will basically add this then method for you invisibly behind the scenes, you could say. And it will give you access to the response data once it's there. So then we get our response here, and we'll wait for this request and response cycle to finish before this data is available and before the next line of code will be executed by Dart. And typically this async await syntax is a bit more convenient, which is why I'm using this here instead of chaining this then method, which you could alternatively also do though. So it's here where we do now have access to this response, and this response object now has a couple of properties that can be helpful. For example, a status code property, which is an integer, which tells us whether the request succeeded or not. There are some standardized status codes you can look for. For example, 200 or 201 tells you that everything worked. 400-ish or 500-ish errors, like 404, tell you that something went wrong. And you might have seen a 404 error before if you visited a website that doesn't exist. So this status code can be used to check whether everything worked. And I'll get back to this later. For the moment, we'll just assume that it worked. And it's then still this response, which has a body with some response data that might have been attached to the response sent back by the server. And it will always depend on the backend and your server which exact data is stored in that body and how it's formatted. In case of Firebase, we can take a look at the official documentation to see what's sent back. And we learn that we get back this JSON data here in a response. This is how JSON data looks like, by the way. It looks a lot like a map in Flutter. And indeed, we can easily convert this back to a map if we wanted to. So it's this kind of data we get back from the response. And in the end, as you can see, it's simply a key named name, which then contains the unique ID that was generated automatically. And this can be useful, and this is something we'll use soon. For the moment, I don't care about it though. I only care about the fact that we do wait for the response to be there. And that's what we are doing here, thanks to await. So for the moment here, I'll just print response body so that we can see it in the console, and I'll print my status code. And with that, we can then pop this screen and go back. Now here, I'm actually getting a warning that I should not try to use the build context across async gaps, which simply means after awaiting, because Flutter doesn't know with certainty whether the context is still the same as before we awaited. If we, for example, navigated away from this widget here in between, so whilst the HTTP request was on its way, a context would be referring to a widget that might not be visible anymore. That's why it's not recommended to use context here like this. Now, to make sure that we're not referring to an outdated context here, so for example, of a widget that's not part of the screen anymore, we can add a if check here and check if this context here is not mounted anymore by using the special mounted property provided by that context object, and checking if that's not the case by adding a leading exclamation mark, which defines a condition where we want this to not be true, because mounted does yield a boolean, true if the widget is mounted, if it's still part of the screen, false if it's not mounted. And with that, we're checking for it being false. And if that is the case, we can simply return here, so that this code does not get executed if the context is not mounted anymore. So in the end, that means that if this widget to which this context belongs is not part of the screen anymore, we return and we don't execute this code. Now here I'm actually still getting that same warning, but this is actually a fine way of using context, and it is an officially recommended workaround. So with that, we will now pop this screen, if we still can, if it still is visible, once this request succeeds. So this will then take us back to the grocery list screen after we successfully sent our data to Firebase and we got back a response. So if we now save this and reload the app, and I add bananas, 12 bananas, for example, you will see that if I click add item, it takes a short while, maybe just a couple of milliseconds, but it only navigates us back to this screen after that time span. Now here we don't see the items yet because we're not loading them yet, and we're not passing them back manually anymore. We'll change this soon, but we can of course see the bananas here in our backend. So that works, and now we're waiting for that response before we go back to the grocery list screen. And therefore now, as a next step, we can finally load the data there, because we now know that we only reach this screen after the post request has been sent to Firebase and the data has been stored there.